Hi, my name is David, and I'm here to give you a quick intro of Meraki's SD-WAN. I'm going to do that by demoing out of our San Francisco headquarters, but really you can see here that I'm on an organization overview page for all of our locations. So as I come in here, you can see that we primarily function out of 3 offices: our headquarters in San Francisco, secondary, our remote office in London, and lastly, we have our office in Sydney. Being that our offices are spread really about as far apart on the planet as we can get them from each other, SD-WAN actually is a really important concept for our network. But really, to introduce it, it's built on top of our auto VPN technology, so I want to lay the underpinnings for that before we move on. As I jump into this appliance status page of the security appliance here in San Francisco, you can see a couple of things. So one, this box has multiple WAN connections already online. Likewise, you can see down here, as I hover over this, that we're actually load dividing some of the traffic that we have going out to the internet really over these 2 different connections. So that's really great, and the MX has been able to do that for a long time, but let's talk about what that means as far as getting our VPN up. So I emphasize this because you can see the cloud has a ton of information about what's happening at this location. So as I want to go set up our site-to-site VPN, this stuff is all going to get used in the background for how it's going to get built. As I jump over to the VPN configuration screen, I'm going to set this to off. Now this is what this page would look like by default. If I just made a new network, I hadn't done any configuration at all, this is where I'd be at. Now I'm going to select what topology I want. I'm going to call this node a hub. This would also create a full mesh. And then you see I get a bunch more information that shows up on the screen. So if I have something that I then want to be reachable over the VPN, I simply go into that network, enable it to be reachable, and now the cloud is going to take all of this information and distribute it out to all the other locations that need to know it. So that way, if I need to go tell London about a new subnet in San Francisco, it's not something I have to set up on both sides. It's something the cloud picks up and distributes out for me, which makes it really, really easy. That's great. Let me jump in and see what does the VPN topology for my network really look like. So as I jump over onto the VPN status page, you can see a couple of things on here. For one, I've got this really cool graphic that's giving me an idea of which location's moving how much data between them. I've got stats over here about how much the VPN is used, and likewise, I've got information about how much latency there is between these locations. Now, I've also got this table. This is going to break out per peer, and you can see I just sorted it to be based on usage. So as I hover over this, you also see it starts to change the graphs that I have at the top and give me ideas about how they relate to these averages. And likewise, you can see it's filtering the chart over on the right to show me how much data am I moving between locations. So that's great. I have now, you can tell that I've got an awesome VPN network that's really distributed and really easy to get an idea of what's going on with it. Now, as I start to scroll down here toward the bottom, you start to get into the stuff that's really specific to the SD-WAN. So here you can see I've got a table of uplink decisions. So this is where am I sending traffic. You can see it's updating in real time. I've got peers over here on the left. So this is traffic that's going to one of these other locations. And over here on the right, you can see information about the policy or decision-making criteria I use to do that. So you can see here I'm failing over if the primary uplink is down. Now, I'm going to grab this connection here in London. I'm going to try to pop this up over here on the side. And as I jump into it, you can see, oh, I actually got a connection to Sydney. You can see as this page loads up, it starts to show me all the different paths that I have between the 2 locations. So if I want to come in here and I want to hover on this, let's say I had an outage or I had a spike in latency, it really helps me correlate across all the different paths that I have what was going on at that time. You can see we're tracking latency, jitter, loss, as well as we're computing a MOS score for each of these connections. That's really important because for us, we have a lot of built-in criteria around real-time apps, and so that's gonna help us a ton to have that info. You can also see as I hover over this custom policy over here, it highlights the graphs so that I can see exactly where I would have been in or outside of this policy. All right, so now I've got a ton of cool info, and these are great charts. You can see I've got some flow preferences and stuff just defined over here. But now let me jump over and show really quickly what it looks like to make one of those policies. So as I jump onto the traffic shaping page, I'm going to scroll down kind of quickly to this VPN traffic because, again, everything's built on top of the VPN, and now I want to make decisions about what to do with that traffic. So if I want to go in here and I want to pick some subnets, maybe these are my 2 voice subnets on either end, and I just want to say any traffic between those. Here I can now implement a policy about uplink selection. So Best for VoIP is a built-in class that we give you to work with, and it actually simply uses that MOS score, and it will just decide what the best link for your VoIP traffic is. So really, really simple to get started. Or if I want to get more specific, maybe I have a private WAN connection and I want to use that for voice first. I can come in here and I say, okay, use that connection and failover if performance is poor and I want to base that around VoIP. Again, another built-in one. Or lastly, you can see, just like I hovered on that previous page, I can define my own. So if I have a particular internal app and I want to make sure that it has specific latency or jitter criteria associated with it, I can set that up. So this has been a quick intro into Meraki's SD-WAN. You can see it's really simple, just like everything we make here. And of course, it's always something you can engage your sales team and get a free trial going if your customer wants to see it in their own network. Thanks a lot.